Hi. So today I will be talking about writing your own REST linter. That might come in handy in case you have some specific needs in terms of security or performance, or you want to disallow certain methods in your code base, in your company. So let's start by who I am. I'm Guillaume Gomez. I'm a Rust language reviewer and contributor. I'm member of a few teams, as you can see. I'm the team leader of the RustDoc team, the tool generating the documentation from your source code. I'm part of the docs.rs team. It's the website where all crates available on crates.io website are generated. It allows you to have access to all documentation from all published crates anywhere, all the time. It's quite convenient. I'm also part of the DevTools team. This team is making available a lot of tools like Clippy, RustDoc, Rust Analyzer, and so much more. So very wide team. And finally, I'm part of the Clippy contributors team. So that's where my experience in Linter comes from. Clippy is the official Rust project linter. So that will be it. And lastly, I'm I'm the organizer of the Rust Paris meetup. So first, let's start with what a linter is. A linter is an extension, in the case of Clippy, of the Rust compiler. It allows you to have some extra help on writing better code in terms of making it easier to read or more efficient, because some lints allows, for example, to detect duplicated or unneeded checks, or even when you are duplicating memory. For example, you are cloning clone and you actually don't use it, you can just send a reference, many things. So a linter is a very important part of any Rust code base, and Clippy is this linter for Rust. Yeah. So how is a Rust linter working? In the case of Clippy, it's a Rust compiler extension. So first it will compiler crate, and then from that it will run its own checks, what we call passes. Then for each lint we register a pass, and it goes through multiple steps and extract that. I will come back to this part later on. So why does it need to be a Rust compiler extension? The reason is that we don't want to rewrite parsing, type checking, borrow checking, and everything. It will be a huge time loss, especially considering that a lot of very talented people are doing it for us. So in our case, in Clippy and in a linter, you basically don't want to do all this work. You just want to use what's existing. So you use the crates that are provided by the Rust compiler directly. So that said, there are some limitations. It can, for example, only work on crates compiled with the same Rust compiler. That limitation is because the Rust ABI is not stable. So files generated with different Rust versions might not be compatible. It's the same limitation as when you build normally using Cargo. When you run Cargo build, if files are from a different version, for this crate it will be recompiled. The Rust API itself is not stable. So remember I said that a linter is a Rust C extension. So in this case, we are very strongly tied with Rust C, meaning that any changes in Rust C need to be done elsewhere in our linter. And that's why this is a big one limitation. Like mentioned, it's tied to a specific Rust C version. That is not so much of a limitation, considering that in Rust we have RustUp, which handles this distribution, so not many things to do. And finally, that limitation is maybe the most weird one. It's annoying to wrap it in a cargo command. You will see why shortly too. So before entering the talks about how the linter is implementing lints and everything, we need to understand how the compiler itself works. Describe quickly in a simplified version of the compiler passes. So here I only wrote 4. First, there is parsing and syntax information. So basically, you have a type, you have its name, generics, fields, and generics and fields and everything. But you don't have type information. You don't know, for example, the argument of this function, which type it is exactly or anything. That comes in the here pass. That's starting to add type information, and that allows you to get, for example, on which type this implementation block is, things like that. Then comes the mirror pass. This one adds borrow checks and much more advanced things that you might need. For example, where this variable is created, destroyed, duplicated, anything. So this is the mirror pass. And finally, this is just for your personal knowledge. It's completely useless for our linter. There is a CodeGen pass. This one is literally translating all the Rust internal information into actual code. For now, by default, we use LLVM, but we plan to add more backends like GCC, and we already have CraneLift, and all of them allows you to have different things. For example, CraneLift is very fast to compile but very slow to run. GCC will hopefully allow you to target a lot more of architectures and have some more checks, and basically everything that GCC is adding, you will have. So now back to our linter. You have 2 kinds of lints. It's very much simplified because there are more, but basically you only need those 2. So the early lint passes only have a syntax information. It's the AST pass. So if you only want, for example, to check that no item or function is using generics, you won't have the need for anything else. If you want to implement a check on syntax or enforce some const style, same. You don't need type information, just early lint and you're fine. However, if you want to, for example, forbid methods like unwrap, you will actually need to check that this unwrap is called on a result or an option, and for that you need type information. So that's basically the 2 big linter passes. The rest is, let's say, not recommended. So to make this a lot simpler, because having to interface yourself with the Rust compiler needs to set up a lot of things, the create Rusty tools allows you to make this a lot simpler. Same for the cargo integration, because you actually need to do some things there as well. All that is provided by the Rusty tools. So the only thing you need to do is to add it in your cargo.toml file, like just showed below. The version is not correct anymore because now it's much more advanced, but you got the main idea. Old file. So normally the first one in cargo.toml is not needed anymore since a few months now, so you can forget this one. But however, the Rust toolchain one is very both interesting and useful. Like I said, to write a linter, you actually need to rely on a very specific Rusty version, and that's what you enter in the channel field in your toolchain. In this case, it means that it's the version of the 6th October of 2020. And from there, we want components, so Rusty dev, because we want the crates of the Rust compiler, rustfmt, because we are not savages, we actually want to be able to have some nicely formatted code, and LLVM tools because we want it to be compiled. And that's pretty much it. Normally, you never need the Rust toolchain file anywhere, but in this case, it will be very important and sadly a strong requirement. So now we enter the interesting part, declaring a lint and the actual code. So The crates starting with RusC underscore are crates coming from the Rust compiler. So in here we need the RusC lint, because after all, we are writing a linter, so we want to be able to send lints, and the RusC session. The Rust compiler, interestingly enough, is making some things able to be done quite, let's not say easily, but makes things simpler for us to declare int. So let's see how to. The declare tool lint takes the name of your lint. What's interesting is that the first line, pub tools ::1 generics. The first tools is how you want to name it. For example, in Clippy, they are Clippy : but in here we are gonna name them tools. Why not? And in this case, we wanted to warn if they are generics. That will be our example. So we call the names like this. And because it's not an internal lint, because you can write lints for your linter, that's another interesting thing, you declare it public. The second is that we want to make it emit a warning by default. There are 3 levels. You can have allow, meaning that unless you are asking the Rust compiler to warn or to deny them, so you will never see about them. So if you have some lints that you only want to enable in some cases, you will put them allow. And if some things are string requirements, you will declare them as deny. And finally, the last line is the description of your lint. So in this case, it warns if any item has generics. And finally, it's more about the lint declaration itself in terms of code. We say that the type that will run the lint pass is called 1 generics, and that our type 1 generics will emit only the 1 generics lint as slices. And like since we only need early syntax information, we don't need any type information because we are only looking for generics and syntax information. We only implement early lint pass for the 1 generics. For now it's empty, so it's basically doing nothing, but we'll continue with that. So now, remember the empty lint implementation? Now we have 1 item. What you need to understand is that the early lint pass and late lint pass, because they are the 2 of them, are following the visitor programming. It's a visitor. So if you don't implement something, it has a default implementation and will basically do nothing. So if you want to only check for the function, you will take a look at check function. If you want to look at any item, you will check at check item. If you want to look at crate, you check crate. You got it. So in this case, you need to look at the Rust compiler documentation to see what is the exact function, what it looks like. So in this case, it takes 3 arguments. It takes your current type, so 1 generics or strict, or empty strings, because it doesn't have fields or information. Then in second argument comes the early context, and that one is actually quite interesting because that's the thing that will allow us to send to lint, to emit the lints, to call anything that you need from the compiler. It's this type. Then third, you have as an item, or an AST item. So you don't need, in our case, we don't need to know what the type of the item is, but you can get this information in the kind of field. Again, all that is available in the compiler documentation. It's very well documented, and I strongly recommend it. So first, you look if the item has generics. In case it has, we check that generics have params. If not, we continue. And if we have params and generics, then in this case, we emit the lint. So as you can see, we call the struct Stepan lint. So first, it takes the name of the lint we are emitting. Second, the location where the lint should be emitted. That is interesting because the Rust compiler works with a long string to store all the source code information. So instead of having strings passed down everywhere, we just have 2 integers. First, the location in that long string, and second, the length. and that is what we call a span. And this span is available in all types provided by the compiler, meaning that in here, the item also has a span, which includes the generic span. But in here, since we want to open the generics, we only show generics.span, and that's it. And then comes the information. So in here, we say not generics here, it's not allowed. That's the message that the users will see. And finally comes a closure taking an extra type, tag. In this case, I don't use it, but you could say, for example, try remove this, try have help messages or anything. You have a lot of possibilities. It's especially useful in case you, for example, want to have a Rust fix to be able to run on your output. In this case, you will say, yeah, please remove this, and based on that, Rust fix will be able to say, okay, removing, and everything is fixed. And now, how do we actually call this linter? And that's our main.rs file. It seems like a lot of code, but it's actually not doing much in this case. So you first take the arguments we receive from cargo. You remove the two first, because first is cargo and second is your command. So in here we called it tools. So we don't need those two arguments, we just remove them. Then from Rust tools, you simply call cargo integration. It will call inside Rust and compile everything and provide all information. You don't need to do anything. That's why we use this crate. Then it takes a closure. Once it's done compiling and everything, you will be able to finally say, okay, I'm registering a lint. Please do that, and when you're done. So in here we say, okay, this is done with lints. It takes a list of arguments, an empty vector, because in this case we don't want any file to force a recompilation. And finally, the last closure has a lint store. So we say, okay, register my lint. It's an early lint, so register an early pass. And in this early pass, we just provide a one generics R type. And that's pretty much it. Everything is set up. It's ready to be run. So in case you never wrote a cargo binaries or binaries in Rust or anything, you can simply run a cargo install --pass, and since it's a local project, your project pass. But it's the same if you have installing any binary from craze.io, cargo install, anything basically. So in this case, I name it tools-inner. You will see why the -inner in a very short moment. So what happens if we run this? It doesn't work. So now that's a very common issue, and sadly very frequent until you guess what why it's not working. So when we run this, actually, it's trying to run with libraries that are not available on the target crates. So when you run cargo clippy, you don't see this because cargo is doing some hack internally and are always distributed with the same Rust version. So they are nicely avoiding this issue. But luckily for us, I have the solution here. So yeah, like I said, not working. So the solution here is simply to say to cargo which Rust version we want to use very specifically. So you can do that with the plus syntax. You provide the channel, the one in our Rust chain file, and say, okay, cargo, with this very specific channel, I want to run my my little cargo binary. That's it. So when this is, sorry, basically I forgot a slide, sorry. Normally you should see a nice result, but you won't see it, so please believe me, it works. So to be able to actually call your binary and not have to have the plus sign, you can trick cargo by writing another cargo binary. This time we'll call it cargo tools. And this function is basically just doing one thing. It's calling cargo and the channel. And that's pretty much it. So let's go line by line. The first one, cargo args, is the same as previously. You take the arguments you get from a cargo. So first, cargo. Second, the name of the command. So we remove that because we are not interested in that. Then the toolchain is the one we know our tool is using. And from that, you just need to write a cargo. You first pass the toolchain argument, then tools inner, because that's the one we want to actually run. And finally, if the user provided the arguments to cargo, you pass them as well. So we run our command, and that's it. And normally, everything should run. In case it didn't, we print a nice message saying, yeah, something failed, and we exit with an error. That's pretty much it. So now we install this new cargo tools. We provide, again, a new path. And instead of running cargo tools-inner, we'll simply run cargo tools, which inside we'll simply call the cargo tools-inner. That's it. So in this case, we simply saw how to write an early linter path. Unsurprisingly, considering there is no borrow checking or any type information, for the need of this presentation, I made it very simple. But if you want to go a bit further and to see how types actually works and having more information about where to find the compiler documentation and everything, you have that available on my website and on this very much longer blog post. Normally, you should cover most of your cases. On the Rusty Tools crate, you have a lot of examples that I wrote showing how to do a few things extra that are obviously not shown in here. And that's it. Thanks for listening. And if you have questions, don't hesitate to come see me.